Hello, everyone. Welcome to my data camp tutorial series. I'm Professor Adam Kroom, and today we will focus on Intermediate R Chapter 4. And Chapter 4 focuses on the apply family. Use lapply with a built-in R function. Before you go about solving the exercises below, have a look at the documentation of the lapply function. The usage section shows the following expression. To put it generally, lapply takes a vector or list x and applies the function fun to each of its members. If fun requires additional arguments, you pass them after you've specified x and fun. The output of lapply is a list, the same length as x, where each element is the result of applying fun on the corresponding element of x. Now that you are truly brushing up on your data science skills, let's revisit some of the most relevant figures in data science history. We've compiled a vector of famous mathematicians, statisticians, and the year they were born. Up to you to extract some information. Instructions. Have a look at the str split calls that splits the strings in pioneers on the colon sign. The result, split underscore math, is a list of 4 character vectors. The first vector element represents the name, the second element, the birth year. Use lapply to convert the character vectors in split underscore math to lowercase letters. Apply to lower function on each of the elements in split underscore math. Assign the result, which is a list, to a new variable split underscore low. Finally, inspect the contents of split underscore low with str. All right, so let's go over here and look on the right and see what we have to do. So this has been completed for us, as well as this. So now we have to convert the lowercase strings. So let's do it like this. Split underscore low, lapply, split underscore math. Boom. Next, take a look at the structure of split underscore low. So to do that, we use str, split low. And let's submit an answer. Great. Head over to the next exercise. All right, use lapply with your own function. As Philip explained in the instructional video, you can use lapply on your own functions as well. You just need to code a new function and make sure it is available in your workspace. After that, you can use the function inside lapply just as you did with base R functions. In the previous exercise, you already used lapply once to convert the information about your favorite pioneering statisticians to a list of vectors composed of 2 character strings. Let's write some code to select the names and the birth years separately. The sample code already includes code that defined select underscore first that takes a vector as input and returns the first element of this vector. Instructions. Apply select underscore first function over the elements of split underscore low with lapply and assign the result to a new variable names. Next, write a function select underscore second function that does the exact same thing for the second element of an inputted vector. Finally, apply the select underscore second function over split underscore low and assign the output to the variable years. So let's go ahead and look over here and see what we have to do. So this first part is already completed for us. And let's see, write function select underscore first. So function x, okay. And then, all right, so here, apply select underscore first over split underscore low. Okay, so let's do this, names, and then L apply split underscore low, comma, select underscore first. Next, we want to write function select underscore second. So select underscore second. And this is going to be function x. And next, apply select underscore second over split underscore low. So let's do it like this. L apply and split underscore low, comma, select underscore second, and submit answer. Nice one. Head over to the next exercise to learn about anonymous functions. Cool. So next exercise is lapply and anonymous functions. Writing your own functions and then using them inside lapply is quite an accomplishment. But defining functions to use them only once is kind of overkill, isn't it? That's why you can use so-called anonymous functions in R. Previously, you learned that functions in R are objects in their own right. This means that they aren't automatically bound to a name. When you create a function, you can use the assignment operator to give the function a name. It's perfectly possible, however, to not give the function a name. This is called an anonymous function. Split underscore low is defined for you. Instructions. Transform the first call of lapply such that it uses an anonymous function that does the same thing. In a similar fashion, convert the second call of lapply to use an anonymous version of the select underscore second function. Remove both the definitions of select underscore first and select underscore second as they are no longer useful. Okay, so let's go ahead and look on the right-hand side and see what we have to do. Transform, use anonymous function inside lapply. Okay, so let's see. We're gonna go names, apply. All right, so this is what we're gonna do. Names, apply, split low. Function x. This is going to be x Let me make sure this is right. So let me see that. Names, I'll apply, split underscore low, function X, boom, X1. Cool, so far so good. Transform, use anonymous function, okay. So next, years, I'll apply, split low, comma, similar to what we have above. And let's give that a shot. Submit answer. Great. Now, there's another way to solve the issue of using the select underscore star functions only once. You can make a more generic function that can be used in more places. Find out more about this in the next exercise. All right, let's move on to the next exercise. Use lapply with additional arguments. In the video, the triple function was transformed to the multiply function to allow for a more generic approach. A lapply provides a way to handle functions that require more than one argument, such as the multiply function. On the right, we've included a generic version of the select functions that you've coded earlier. It takes a vector as its first argument and an index as its second argument. It returns the vector's element at the specified index. Instructions. Use lapply twice to call select underscore el over all elements in split underscore low. Once with the index equal to 1 and a second time with the index equal to 2. Assign the result to names and years respectively. All right, so let's go over to the right side and see what we have to do. Pioneers. Okay, split. Okay, split low. Generic select function. All right, so what we have to do is work down here. Use lapply twice on split underscore low. Names and then assign the results to names and years. Okay, so first assigning it to names, assign, lapply, then we're gonna go split underscore low, comma, select underscore el, comma, index, set to 1. And then the next one's going to be assigned to years. So years, assign, lapply, and essentially same. So I'll just copy and paste it. But instead of index 1, we'll just swap that to index 2. And let's see. Submit answer. Awesome. Your lapply skills are growing by the minute. Cool. Let's press enter to continue. Apply functions that return null. In all of the previous exercises, it was assumed that the functions that were applied over vectors and lists actually returned a meaningful result. For example, the to lower function simply returns the strings with the characters in lowercase. This won't always be the case. Suppose you want to display the structure of every element of a list. You could use the str function for this, which returns null. This call actually returns a list the same size as the input list, containing all null values. On the other hand, calling this on its own prints only the structure of the logical to the console, not null. That's because str uses invisible behind the scenes, which returns an invisible copy of the return value, null in this case. This prevents it from being printed when the result of str is not assigned. What will the following code chunk return? Split underscore low is already available in the workspace. Try to reason about the result before simply executing it in the console. Okay, so look at this, and I'll give you a moment to think about it. And let's go with wonderful. Feel free to experiment with some more with your code in the console. Did you notice the lapply always returns a list, no matter the input? This can be kind of annoying. In the next video tutorial, you'll learn about sapply to solve this. So we'll go ahead and skip the video. Feel free to watch it on your own time, but we'll continue with the exercises. How to use sapply. You can use sapply similar to how you used lapply. The first argument of sapply is the list or vector x over which you want to apply a function, fun. Potential additional arguments to this function are specified afterwards. In the next couple of exercises, you'll be working with the variable temp that contains temperature measurements for 7 days. Temp is a list of length 7, where each element is a vector of length 5, representing 5 measurements on a given day. This variable has already been defined in the workspace. Type str temp to see its structure. Instructions. Use lapply to calculate the minimum built-in function min of the temperature measurements for every day. Do the same thing, but this time with sapply. See how the output differs. Use lapply to compute the maximum max temperature for each day. Again, use sapply to solve the same question and see how lapply and sapply differ. All right, so we'll go over here. Use lapply to find each day's minimum temperature. So lapply temp min. Use sapply to find each day's minimum temperature. Sapply temp min. Use lapply to find each day's maximum temperature. Lapply temp max. Max. And finally, use sapply to find each day's maximum temperature. Sapply temp max. Submit answer. Nice. Can you tell the difference between the output of lapply and sapply? The former returns a list, while the latter returns a vector. That is a simplified version of this list. Notice that this time, unlike in the cities example of the instructional video, the vector is not named. Move on to the next exercise. Sapply with your own function. Like lapply, sapply allows you to use self-defined functions and apply them over a vector or a list. Here, fun can be one of R's built-in functions, but it can also be a function you wrote. This self-written function can be defined beforehand, or it can be inserted directly as an anonymous function. Instructions. Finish the definition of extremes underscore AVG. It takes a vector of temperatures and calculates the average of the minimum and maximum temperatures of the vector. Next, use this function inside sapply to apply it over the vectors inside temp. Finally, use the same function over temp with lapply and see how the outputs differ. All right, so first thing we have to do is finish function definition of extremes underscore AVG. So function, and x goes there, min x plus max x. Apply extremes underscore AVG over temp using sapply. So sapply temp extremes underscore AVG. And next, apply extremes underscore AVG over temp using lapply. So lapply temp extremes AVG. Submit answer. Great job. Of course, you could have solved this exercise using an anonymous function, but this would require you to use the code inside the definition of extremes underscore AVG twice. Duplicating code should be avoided as much as possible. Continue, press enter to continue. All right, so next exercise, sapply with function returning vector. In the previous exercises, you've seen how sapply simplifies the list that lapply would return by turning it into a vector. But what if the function you're applying over a list or a vector returns a vector of length greater than 1? If you don't remember from the video, don't waste more time in the valley of ignorance and head over to the instructions. Instructions. Finish the definition of the extremes function. It takes a vector of numerical values and returns a vector containing the minimum and maximum values of a given vector, with the names min and max respectively. Apply this function over the vector temp using sapply. Finally, applying this function over the vector temp using lapply as well. So let's look over to the right side and see what we have to do. First thing we have to do is create a function that returns min and max of a vector. Okay, so to do that, we need to max equals to apply extremes over temp with sapply. So sapply temp extremes. Apply extremes over temp with lapply. So this time use lapply over temp, right? So temp and then extremes. Cool. Submit answer. All right, so what happened here? 8 sapply temp extremes. Let me make sure I didn't make a mistake. Oh, yeah, so my mistake was there. All right, great. So again, make sure that You don't make any minor errors. So here, I needed this to be an X. I don't know why I accidentally typed in a C. Yeah, maybe because it's 2:19 in the morning. Wonderful. Have a final look at the console and see how sapply did a great job at simplifying the rather uninformative list of vectors that lapply returns. It actually returned a nicely formatted matrix. Cool. So let's go ahead and continue. Next exercise is sapply can't simplify. Now what? It seems like we've hit the jackpot with sapply. On all of the examples so far, sapply was able to nicely simplify the rather bulky output of lapply. But as with life, there are things you can't simplify. How does sapply react? We already created a function below underscore zero that takes a vector of numerical values and returns a vector that only contains the values that are strictly below zero. Instructions: apply below underscore zero over temp using sapply and store the results in freezing underscore s. Apply below underscore zero over temp using lapply. Save the resulting list in a variable freezing underscore one or L. Next, compare freezing underscore S to freezing underscore L using the identical function. All right, so let's go over to the right side and see what we have to do. Okay, so apply below underscore zero over temp using sapply. And then, so like this. Freezing underscore sapply temp below zero. And similarly, freezing underscore lapply temp below zero. And then our freezing underscore s and freezing underscore L identical. Let's use the identical function. Identical freezing s, comma, freezing L, and submit answer. Nice one. Given that the length of the output of below underscore zero changes for different input vectors, sapply is not able to nicely convert the output of lapply to a nicely formatted matrix. Instead, the output values of sapply and lapply are exactly the same, as shown by the true output of identical. Press enter to continue. All right, next exercise is sapply with functions that return null. You already have some apply tricks under your sleeve, but you're surely hungry for some more, aren't you? In this exercise, you'll see how sapply reacts when it is used to apply a function that returns null over a vector or a list. A function, print underscore info, that takes a vector and prints the average of this vector has already been created for you. It uses the cat function. Instructions: apply print underscore info over the contents of temp with sapply. Repeat this process with lapply. Do you notice the difference? So we'll go over to the right and think about what we have to do. So the first thing we have to do is apply print underscore info over temp using sapply. So using sapply, this is how we do that. Next, apply print underscore info over temp using lapply. Lapply temp print info. Submit answer. Great. Notice here that quite surprisingly, sapply does not simplify the list of nulls. That's because the vector version of a list of nulls would simply be a null, which is no longer a vector with the same length as the input. Proceed to the next exercise. All right. So our next exercise is reverse engineering sapply. Without going straight to the console to run the code, try to reason through which of the following statements are correct and why. 1. Sapply can't simplify the result that lapply would return and thus returns a list of vectors. 2. This code generates a matrix with 3 rows and 2 columns. 3. The function that is used inside sapply is anonymous. And 4. The resulting data structure does not contain any names. Select the option that lists all correct statements. So, the function that is used inside sapply is anonymous. And this code generates a matrix with 3 rows and 2 columns. Submit answer. Great. This concludes the exercise set on sapply. Head over to another video to learn all about VApply. All right, so we will go ahead and skip this video so we can get straight to the next exercise. And this exercise is use VApply. Before you get your hands dirty with the third and last apply function that you'll learn about in this intermediate R course, let's take a look at its syntax. The function is called VApply, and it has the following syntax. Over the elements inside X, the function fun is applied. The fun.value argument expects a template for the return argument of this function, fun. Use.names is true by default. In this case, VApply tries to generate a named array if possible. For the next set of exercises, you'll be working on the temp list again that contains 7 numerical vectors of length 5. We also coded a function, basics, that takes a vector and returns a named vector of length 3, containing the minimum, mean, and maximum value of the vector respectively. Instructions. Apply the function basics over the list of temperatures, temp, using VApply. This time you can use numeric 3 to specify the fun.value argument. Okay, so let's come over to the right side and think about what we have to do over here. Apply basics over temp using VApply. So using VApply means doing this over temp, basics, fun.value, and let's submit answer. Perfect. Notice how, just as with sapply, VApply neatly transfers the names that you specify in the basics function to the row names of the matrix that it returns. Press enter to continue. Next exercise is use VApply. So far, you've seen that VApply mimics the behavior of sapply if everything goes according to plan. But what if it doesn't? In the video, Philip showed you that there are cases where the structure of the output of the function you want to apply, fun, does not correspond to the template you specify in fun.value. In that case, VApply will throw an error that informs you about the misalignment between expected and actual output. Instructions. Inspect the code on the right and try to run it. If you haven't changed anything, an error should pop up. That's because VApply still expects basics to return a vector of length 3. The error message gives you an indication of what's wrong. Try to fix the error by editing the VApply command. All right, so definition, functions, mean, x, median, x, max. Fix the error. Okay. So what we need to do is we need to change the temp basics. Great job. Head over to the next exercise. From SSupply to VApply. As highlighted before, VApply can be considered a more robust version of SSupply because you explicitly restrict the output of the function you want to apply. Converting your SSupply expressions in your own R scripts to VApply expressions is therefore a good practice and also a breeze. Instructions. Convert all the SSupply expressions on the right to their VApply counterparts. Their results should be exactly the same. You're only adding robustness. You'll need the templates, numeric 1 and logical 1. Okay, so let's go over to the right-hand side and look what we have to do. Convert to VApply. So it's in SSupply right now. We got to convert that to VApply. So let's do it this way. VApply temp max fun value numeric All right, and then next we need to convert to VApply. So VApply temp function x, y. So mean x greater than y, y equals 5, fun dot value equals logical. So we converted to VApply. Submit answer. Great. You've got no more excuses to use SSupply in the future. Press enter to continue to the next exercise.